So let me introduce you guys to the idea of continuity. I hope I spelled that right. So what is continuity? So continuity, specifically for Calculus 1, describes a graph. And this graph doesn't have any holes, it doesn't have any discontinuities, or the function is basically not separated in any way. So how would you guys describe continuity? Pause the video, think about it. What do you think is the definition of a continuity? Because this right here, this function is continuous, right? But what if you had a function that was like this? Oh, why is this discontinuous? And why is the green discontinuous, right? And why is the red continuous? So take a pause, take a guess. All right, now that you've taken a guess, I'll tell you the formal definition of continuity. So the formal definition of continuity relates to limits. Ooh. Well, the first obvious one isn't a limit. It's just that for every single point on your function, so for every single point on your function, a must equal something. Literally, every single point on your function must have a value. So at, let's say, I don't know, x equals -2 approximately here. This kind of looks like -2. Well, your green graph doesn't have anything there. Maybe it could be here, but it's not. Your graph completely cuts off. There's no graph between these two white boundaries. So this is already discontinuous because it doesn't follow this law. For every single point on your function, it must have a value. Now, how about for the limits now? We'll use limits now. So basically, another one is for every single point on as x approaches a, or a some point on your graph, it must exist as well. So rather than something, let's use exist rather than, so the math teachers don't get mad. So every single limit must exist. Well, when does a limit not exist? Well, a limit doesn't exist if you take the one-sided limits. So let's say you had a function like so. I don't know, it doesn't matter, squiggle a little bit at the end. You took a function, and this was at x equals -3. And the one-sided limits, so when x approaches -a, and when x approaches positive a from the positive side. So when x approaches a from the positive side, and when x approaches a from the negative side. Not -a, I meant approaches a from the negative side. Then your one-sided limits must all have the same values. But in this orange case, well, if you approach -3 from the left, you will get some value, I don't know, let's say y equals 5 here. But if you approach from the right, you'll get some value like 4. So the one-sided limits aren't equal to each other for f of a in the case of the orange. So a limit must exist for every single location. And what else to have? We have one more condition. What is that condition? Well, I'll give you a little hint. I'll give you a little hint using our graph here. So let's say there was a hole here, but there is a defined point on this function. This point still exists at x equals 3. So if you were to plug in f of 3 for the red function, let's actually write this with red so you guys know. So if you approach f of 3 with the red function, you would get 0, right? Because the y value at this function is 0. There's still a point that exists here. If you took the limit here, well, if you took the limit here, you still have a hole here, but the limit would be maybe some point, this would be like 4, right? So y value of 4 at this point. So if you took the limit as your function, as your x value approached 3, so x equals 3 on your red function. So if you took the limit as x approached 3, you would get 4. Now the function value of f of 3 is equal to 0, which is this point here. And your limit which is 4, do not match. So would you consider this red? Would you consider this red function continuous? It's not continuous at x equals 3. So this red function is not continuous at x equals 3. And the reason why is because the function value must exist, must be equal to the limit value at that function point. So the function value must equal the limit. And if that was the case, then you wouldn't have a hole here, and your limit and your function would all be equal to each other. That is if you patch this hole. Now, there's different types of discontinuity. There's non-removable and removable discontinuity. And I'll be talking about that in another video. Link will be down in the description. It's a somewhat different topic, but it can be covered in a really quick amount of time. But these 3 rules are your formal definition of a continuity. Now, if you're taking AP Calculus, AP Calculus uses the one-sided limit. So instead of the limit exists at every point, the one-sided limits equal to each other. At least that's what I was taught in AP Calculus. But honestly, this has the exact same definition. So depending on your rubric, or maybe the rules change every year, just keep that in mind. Now, AP Calculus will make you memorize this definition of continuity because it's going to be important for differentiability, and sometimes they just make you write down the rules. I had a test where just literally my teacher just made me write down the rules, like these 3 things. Like, what is the definition of continuity? Like, there's literally nothing else. Literally, we're 10 points, like 10% of the entire test. What is the definition of continuity? So make sure you memorize these, but you can honestly just ingrain this using logic. But as always, if you have any questions, put it down in the comment section. And if you found this video helpful, consider subscribing and liking the video. Thanks for watching.